Hello, everybody. Welcome to section 1.8. This section is on inequalities. So the thing to remember about inequalities is that they're just another kind of equation. So inequalities are just another kind of equation. And for these equations, instead of using equal signs, obviously we use these symbols here. So greater than, less than or equal to, greater than or equal to. The thing to remember about these is, so I always think of it as an alligator. That was what I was taught in grade school, and I think it's helpful. So you just have to remember that the alligator, so like this guy here, right? Imagine there's teeth. Maybe he's got an eye, right? Wants to eat the bigger number. Right? So like equations, inequalities have certain rules that they follow. So let's take a look at those rules. So let's see the first one. If we've got A less than or equal to B, and here A and B can be numbers, they can be terms, just kind of anything, right? So if we have like some equation that says A is less than or equal to B, then we can say that A like plus C is less than or equal to B plus C, right? So we can add something to both sides and it stays true, right? We can also subtract C from both sides if we want, and it stays true. So we can do A plus C is less than or equal to B plus C, or we can do A minus C is less than or equal to B minus C. Similarly, I mean, we could also, you could take something that looks like this, and then if you know that like the C's are the same, you can actually go backwards and get rid of them, right? And you still have A is less than or equal to B. Cool. All right, now, if C is positive or 0, then we say A less than or equal to B. We can multiply both sides by C. So AC is less than or equal to BC, right? And we could also divide both sides by C to go back the other way, right? And if C is negative, the only change now is that when we multiply both sides by C, be careful, the inequality flips. Okay, so it changes. But then if you divide by a negative number, the same thing, it flips back around again. So we can multiply and divide inequalities on both sides by any number we want. We should be careful because if we multiply or divide by a negative number, the direction of the inequality flips. So you just got to keep that in mind. That's an important rule. Okay, let's look at another. So if we have that, A and B are both positive without being 0, then we can say that if we have 1 over A is less than or equal to 1 over B, then what happens is we can say that A is greater than or equal to B. So when we like flip things around the reciprocal, the sign also changes. And I mean, we can flip it over the reciprocal again, change the direction of the inequality again, and we could go back the other way as well, right? So, but this only works for positive numbers, so just bear that in mind. All right, and then if we have, let's see. So if we have A less than or equal to B, so if we have this inequality, and we have another inequality, like C is less than or equal to D, then we can combine them, right? And we could say that the two smaller things added together are going to be less than or equal to the two bigger things added together, right? Which kind of makes sense. So if you have something smaller than something else, and then another thing smaller than something else again, you put the two smaller things together, they're going to be smaller than the two big things put together. So This kind of makes sense. And then lastly, if we have A smaller than B, and we know that B is then again smaller than something else, C, then we know that A is smaller than C, right? Which kind of makes sense. You wouldn't want something to be both smaller and bigger than something like this. So if A is smaller than B and B is smaller than C, then A is smaller than C, which is good. The key ones to remember when we're dealing with inequality are these three right here. These are the key ones, I think. These will be most helpful when you're solving inequalities. So I keep talking about solving them. Let's see this in action. Let's see an example. All right, so find all solutions for x in interval notation. Because inequalities, their solutions are oftentimes intervals or sets. And then we're going to look at the inequality. Let's do 4x is less than 8x plus 2. All right, so I think what I'm going to do first is I'm going to subtract 8x from both sides. So I'm going to bring all the x's over to one side. And so then we do that, we get 4x minus 8x is negative 4x. And then over here, these cancel and we get less than 2. That's using this first rule right here. Right, so I've subtracted the same thing from both sides. Good, okay. Now I'm gonna divide both sides by negative 4. We don't need that there. I'm gonna divide both sides by negative 4, and that's using this third rule here. I'm dividing by a negative number, right? So these negative 4s will cancel, we get x, but then because we're dividing by a negative, this sign flips. We get x is greater than 2 over negative 4, which is just negative 1/2. So we have x is greater than negative 1/2. Cool, and so in interval notation, what this looks like is the solution set is all things strictly greater than negative 1/2. So this would look like this. Cool. Let's move on to maybe something maybe a little trickier. So for harder, and by harder I mean quadratic inequalities, there are steps that we can follow to kind of solve them. So these steps are, 1, first you're going to move all terms to one side. So that means you're going to get like something greater than or equal to 0 or less than or equal to 0, right? So we want 0 on one of the sides of the equation. Then once you have that, you're going to factor the side that isn't 0. Then you're going to determine where each factor is 0, and we'll talk more about what that looks like in a minute. And then once you have that, you're going to make a table. Again, we will talk about more of that in just a sec, and then solve. But these last 3 steps will make a little more sense once I show you an example. So let's do one. Let's solve, let's do x squared less than or equal to negative 2x plus 3. Okay, so the first step is to move all the terms over to one side. So I'm going to take these and I'm going to move them over. So I'm going to add 2x both sides and subtract 3 from both sides. So I get x squared plus 2x minus 3 is less than or equal to 0. Cool. All right. The second step says we need to factor. So I'm going to use the AC method. And I see that, let's see. I want something times something equals AC, which in this case is going to be -3, and something plus something equals B, which in this case is going to be 2. And if you stop and think about it for just a little bit, you might find that you can do -1 and 3. So then our factoring becomes x minus 1, x plus 3, because A was just 1. And we know that this can be less than or equals 0. Cool. So now the next step is to determine where each factor is 0. And so now by factor, what I mean is this is a factor here in the red, and this is a factor here in the blue. Okay. So 3. X minus 1 is 0 at x equals 1, right? Because if we plug in 1 there, this goes to 0, and then this one is 0 at x equals, not 3, sorry, -3. And if you wanted to see that in more detail, for example, if we want to look at the second one, what you would do is you would do x plus 3 equals 0, and then that, you can subtract 3 from both sides to get x equals -3. And so that's where that comes from. And so now we know that our zeros are 1 and -3, which is good because now we can do number 4, which is make a table. And what I mean by that is, oops, you might have something that looks like this. So we have, do the x minus 1 factor here and the x plus 3 factor here. And then I'm going to do x minus 1, x plus 3. So like our whole expression that we care about. And then here I'm going to break up intervals based on where our zeros were. So we have our first 0 is at -3. So I'm going to do -infinity to -3. And then -3 to our next one is 1. And then I'm going to do 1 to infinity because that was our last 0. Okay, cool. And so now what we're going to fill this table in with is we're just going to look at whether the term is positive or negative. So if we look, for example, in this first slot here, we're looking at things less than -3. And so if we just pick one like -4, right, we see that if we do -4, so -4 minus 1, that's equal to -5. So that's negative. So we're going to put a negative here, right? And then if we do -3 to 1 right here, let's just pick like 0. 0 is in there. So we get 0 minus 1. That's -1. That's still negative. So we're going to put a negative here. And then here, for this one, we can pick 2. 2's in that interval. Oops. And so then we have, like, for example, 2 minus 1, which is 1. That's positive. Okay, cool. So that's positive. And for the next one, if we look at this, we have, let's pick our same point. So we have x, or sorry, not x. We're going to plug in -4 for x plus 3 because we're dealing with this one now. And that's going to be equal to -1. So that's negative. And then we have 0 plus 3, the next point. And that's going to be 3, and that's positive. And then lastly, we have 2 plus 3 is 5, and that is positive. So we can fill this in. That's positive. That's positive. And now for this last row, what we're going to do is we're going to do negative times a negative, because there's multiplication here. Negative times a negative, that's positive. Negative times a positive is negative. And positive times positive is positive. Cool. So here's our table. And now we're like, all right, why do we care about that? Well, what we wanted to know, if you remember, is we want to know where x, what was it exactly? -1, x plus 3, right? We wanted to know where that is less than or equal to 0. So we wanted to know, like, where is this? So i.e., where is x minus 1, x plus 3 negative? Right? And the answer is up here. We want to look down at this bottom row where we have x minus 1, x plus 3, and we want to, like, where is it negative? And we're like, ah, right here. So we know that the answer is going to have something to do with negative 3 to 1. Now the question is it closed or open interval? And it's going to be closed because we're dealing with less than or equal to. If it were just less than, then it would be open interval. But because it's less than or equal to, the answer is going to be closed interval, negative 3 to 1. Cool. All right, so those are quadratics. Let's look at maybe something even trickier. Let's look at rational inequalities. Luckily, the same procedure for quadratic inequalities holds for rational inequalities. So let's do this. Solve, and let's do x, and let's say we have it already factored for us. So let's say we do some math and we get something like this, right? We moved some things around, we added, we did whatever we needed to do to our rational inequality to get something that looks kind of like this. We want one fraction and we want everything as factors as we possibly can. And so now if we look at this, we have 3 factors. We have this thing, we have this thing, and we have this thing. So we have our 0 factors. Oops, come on. So our factors are 0 at. So the blue one is 0 when x equals 0. So you have 0. The green one you can solve, and you'll find that it's 0 when x equals 2. You can plug that in. 2 minus 2, 0. That checks. And then the other one is just the opposite sign, and it's negative 2. So here are our zeros, which is good. Okay, so now we're going to do a table like we did last time. This time it's going to be a little bit bigger because we've got more things. Let's see, 1, 2, 3, 4. I think that's all I need. So then we've got x, and then we've got this factor, and we've got this factor. And then lastly, we'll have like the whole thing. All right, and then we want to break up our interval 0 to a negative 2. So the first one there is negative 2. So we do negative infinity to negative 2, and then negative 2 to 0, and then 0 to 2, and then 2 to infinity, like that. Okay, cool. So now we can go ahead and fill out this table. And so I'm just going to go ahead and fill out the first line, and then I'll just fill in the rest because time. But obviously, if you plug in a negative number for x, that's going to be negative. If you plug in somewhere between negative 2 and 0, that's all negative. So that's going to be negative again. And this one, same idea, is positive. This one is positive. And then if you do these kind of procedures to all of them, picking a point, you get a table that looks like this. Okay, cool. And so now to fill out the bottom row, we have a negative times a negative here and here. That's a positive. But then times another negative is negative. So this is going to be negative. This one's negative times a negative is a positive times a positive is positive. This one, similarly, positive times negative is negative times positive, negative again. And then this one's all positive. So that's just positive. Cool. Now we have to go back and remember, what are we trying to do? So we want to know this, which is where is it positive? right? We're asking where is it bigger than 0? So where is it positive? And so if we look at our table that we made, we have it here and here, which means that our answers are going to be some form of -2 to 0 and 2 to infinity. So now the question is open or closed? Well, if we go back up and we look, we see that we have a strict inequality. So we're going to be dealing with open. So our answer will be closed -2 to 0, and then 2 to infinity. And then we're going to, it's both of them together, right? They're both part of the solution set. So it's going to be oh, sorry, my bad. These should not be brackets. I just said they should be open. There we go. But yeah, so both those intervals are part of the solution set. So we're just going to union them together and they say this is our answer. All right, cool. Now there's one more kind of inequality that we're going to be dealing with a lot. And these are absolute value inequalities. All right. So in general, the pattern that you might see with these is that if you have absolute value of A is less than or equal to B, then that's gonna, the solution set's gonna look something like -B less than or equal to A less than or equal to B, right? And so that might look like an interval like this on the real line. And then if you have the other way around, so if you have greater than or equal to B, then you're gonna get a solution set like B is less than or equal to A, or B is less than or equal to -A. And so what that will look like is this, kind of on the real number line, right? So that's kind of, if you see a certain kind of structure to them, these are the kind of solution sets you can expect to see. So let's go ahead and take a look at an example of both of these, right? So let's do one first. Let's look at, let's do find all solutions for x. So let's do 2x plus 5, all in absolute values, and let's do greater than 3. So when we're doing absolute value inequalities, just like solving absolute value equations, you're going to first want to make sure that the absolute value is alone on its side of the inequality. And in this case, we already have that, so that's good. And so we'll go ahead and look at the two cases. So case one, because absolute values are cases, is that we just have 2x plus 5 is greater than 3. And then the other one, of course, would be negative that. Okay, but let's look at the first one first. So then if I subtract 5 from both sides, I get 2x is greater than or equal to -2. And then I'm going to divide it on both sides by 2, a positive number. So the inequality stays the same. I get -2 over 2. And that's just going to be x greater than 1. Good. And then for the other one, we can distribute this negative inside like this. So you get -2x minus 5 greater than 3. Add 5 to both sides, get -2x is greater than 8. And then divide both sides by -2 is a negative number. So the sign is going to flip where x is less than 8 over -2, which is x is less than -4. So here are our two parts of the solution. So x is, so if we draw these on a real number line, right, got 0 here, some ticks. So we have x is strictly greater than 1, so that would look like this, right? And the other one, we draw another number line. We have x is strictly less than -4, so that would look like this, right? And so when we're looking at the solution set of this, we're going to union it. So it's going to be, so from the red one, we have, actually, let's do the blue one first. From the blue one, we have it's -infinity to -4, right? parentheses because it's strictly less than. And then union, the red, is going to be 1 to infinity. And that would be our answer for this inequality. And then if we look at the other kind, or sort of like the other structure to the solution. So for example, let's say we have absolute value of 2x, and then we're going to plus 2, and then less than or equal to 5. So if we move the 2 over, because we need to, because we want to get the absolute value on its own, so we're going to subtract 2 from both sides. We get 2x is less than or equal to 3. And then what we can do, instead of splitting up into cases, for this one, or actually, yeah. So when you have absolute value less than or equal to a number, instead of doing the greater than case where we split it up like this, when we have less than, we're going to write it like this. It'll be -3 less than or equal to 2x less than or equal to 3. And so this is by this rule up here, because we're in this case now, right? Whereas this first example was this case. So we have this structure, and this might look scary because there's 3 things, like there's 2 inequalities, but what we're going to do is we're just going to manipulate all 3 of them at once. And so our goal here is to solve for x, and so we're going to divide everything by 2. So divide by 2, divide by 2, divide by 2. 2 is a positive number, so the inequalities stay the way they are, and we get -3 halves less than or equal to x less than or equal to 3 halves. And so if we draw this on a real number line, 0, x is between -3 halves inclusive to +3 halves inclusive, and it looks like this, right? And so our answer would be including -3 halves to 3 halves. Cool. Absolute value inequalities are a little tricky because there are 2 cases, and you have to kind of be cognizant of whether you're dealing with less than or equal to or greater than or equal to. But overall, once you understand like kind of the steps to solving inequalities in general, they are relatively straightforward, which is nice. Anyway, keep working on your studying, and I hope to see you in office hours.